So hello uli and welcome back. In this video, we'll discuss evaporation as part of thermodynamics or using steam tables rather. But it's also a unit operation. So what are we waiting for? Let's start. So please take note that as a unit operation, magkakaiba po ang evaporation sa dehydration and distillation. The only thing common with them is that there is removal of water, but the product state in evaporation is mainly liquid as opposed to dehydration where you have a solid product, and distillation which is having a solid or liquid product. Note that in distillation kaya maraming bar strand because the liquid removed is being fractionated so that the remaining liquid will have different concentrations depending on where in the distillation column you collect the liquid or gas. But of course, ang discussion natin talaga is for evaporation, so we'll focus there. So here's just a schematic for differentiation in evaporation. This is a type of evaporator. Yung feed mo papasok dito sa gitna. Posibleng ini-spray siya tapos since it's heated, the vapors would go up here and the concentrated liquid could go down here. In dehydration, you have particulate solid products. In this case, it's a fluidized bed dryer. Papasok dito yung solid products, hot air is blown from underneath, and that causes liquid to vaporize from the product, thereby leading to a concentrated product and vapors released up here. Meanwhile, in a distillation column such as this one, so yung pinaka-feed mo ay ito, papasok siya dyan, bababa siya, while the vapor flows up. No? So it causes an evaporation of the vapor, and then meron kang dalawang kinokollect, yung liquid na naiiwan sa ilalim, and then dito sa part na bumabalik sa reflux drum, okay, may part na babalik sa distillation column and may part na kukunin na as product. But we will not discuss this as it's not the coverage of our session. So recall your boiling point elevation, di ba? Kapag meron tayong isang product and as it increases its solids content, tumataas din yung boiling point niya. Case in point, when you have sugar in water, as the solution concentrates, the boiling point also increases. So therefore, actually, if it's a batch process, it's not actually in a continuous or steady state, no? Kasi pabago-bago yung boiling point mo over time. Alright, so here we have a definition, yung tinatawag nating effect, individual subunits of an evaporator system. So in this case, this is a triple effect evaporator with the first, second, and third effect. So may kita niyo minsan sa mga problems in a single effect, double effect, triple effect evaporator, so on and so forth. So first question natin, sir, bakit ba kailangan may effect pa? Di ba pwedeng single effect na lang lahat? Kasi feeling namin, pag mas maraming effect, mas mahirap yung calculation. Well, tama naman kayo, mas mahirap nga talaga. I'll illustrate this first now before I answer the question. So the concentrated feed enters through here. It goes through the evaporator. So may water vapor na lalabas dyan. And then, yung product mo naman, slightly more concentrated, lalabas dito, papasok as feed naman for the second effect, mako-concentrate uli, and then papasok as feed for the third effect, then mako-concentrate, and then saka siya lalabas as product. If you notice on the other hand, yung vapor or water vapor na nag-evaporate dun sa first effect mo, imbis na itapon, ito actually ang ginagamit bilang pang-init dun sa second effect ng evaporator, and the vapor produced dun sa third effect ay ginagamit pang-evaporate dun sa third effect ng evaporator. So simply put, iisang beses ka lang nagpasok ng steam, pero yung heat transfer doon, nung nag-condense na yung steam na yon, gagamitin mo naman ngayon yung steam na nanggaling dun sa product para initin ulit yung mas concentrated na product. So mentally, you could say, of course, that the first effect should be the largest and nagiging less and less hanggang sa maging negligible na lang yung effect ng further evaporators. No, typically, having more than 5 effects is sobrang doon na nagkakabawian yung costing, no, na parang hindi na sulit magkaroon ng more than 5 effects ng evaporator. Pero yun nga, bakit ba ginagawa to? Well, yun nga, una is to reuse the steam, the water that vaporized from your previous effects. Kasi nga, energy balance, heat transfer, di ba? So, yung heat na yun, sayang naman kung itatapon na lang natin yung init. So, gagamitin natin siya uli. Alright? Okay, when we say heat exchanger, it is any device used for heating or cooling of food. So they may work in different ways. Each one may look different. But as long as their use is for the heating and cooling sa food processing, then heat exchanger ang tawag natin sa kanila. Usually also, the heat exchange happens without transfer of mass, no? So, kumbaga, pag tinignan mo yung stove mo, mag-iinit ka ng tubig doon, hindi naman bibigat yung tubig mo kasi init lang nung burnt LPG yung napupunta compared to, let's say, pag nag-steam ka ng siomai, you are heating the food but they're also causing mass transfer from the system and the surroundings. Although actually meron ding heat exchangers na may heat and mass transfer, pero for the most part, we'll go with those na walang mass transfer kasi mas mahirap pag meron. Okay, and fouling, which is simply the buildup on the surface of heat exchangers. So, pwedeng ito yung mga scaling like yung calcium ion sa water mo, etc. Or nag-form ng rust or maybe ice crystals kung cooling yan. And all of these generally reduce the heat transfer capacity kasi whatever that is, mas pinapakapal mo yung tubo mo or yung material na nagbe-build up ay hindi same ng heat transfer coefficient compared dun sa metal na kung saan siya gawa. Okay, when solving problems, you will usually be asked for what we call steam requirements and or steam economy. So, steam requirements refer to the mass or mass flow rate of steam needed in a batch process or continuous process. So, typically, pag batch process, mass lang siya. Like, sa isang batch na ganit 300 kilos ng orange juice concentrate, ilang kilo ng steam ang kailangan mo. Kung continuous process, like let's say you have ice cream pasteurization at 600 liters per hour, then how many kilograms per hour of steam do you need? Steam economy, on the other hand, is just the ratio of the kilograms of water evaporated per kilogram of steam generated. So typically, kapag mas marami kang na-evaporate na tubig sa ginamit mong steam, mas mataas yung steam economy. So the higher number, the better. And this is usually a fraction. Unless superheated yung steam mo, pwede naman actually siyang mag-exceed ng 1 in value for this. Okay, why is there a need to evaporate or rather concentrate products? So, two things, no? When you're concentrating the solids in the product through the use of evaporation, such as when you have sugar, then you are making it more shelf-stable in terms of microbial spoilage, no? So, alam natin, halimbawa, yung mga juice concentrates from naturally high sugar fruits, they don't spoil as easily as the juices na hindi dumaan sa ganung process. And also, you would lower transport costs because transport costs are based on mass and volume, and if you could significantly decrease the mass and volume of a product, then all the better. Kaya minsan inisip nyo, di ba, yung mga fresh milk na kinuha mo mula sa gatas halfway around the world, tapos papadala mo sa barko, and that's 90+% water. Why don't you just turn it into, let's say, powder and just reconstitute it? Well, for milks, walang masyadong concentration na nangyayari kasi pwede namang rektahin na gawing powder and i-reconstitute na lang. Pero for most, let's say, juices, and especially fruit juices, we use concentration pa rin. So, two disadvantages. First is the having to design a system. Nakita niyo naman, daming effect ng evaporator. Pag visualize na sa totoong buhay, na minsan yung mga evaporator na yan, they are very big pieces of equipment, and I mean, kasing laki ng building big, like those tower type of evaporating equipment are literally like 3 or 4 stories high, no? And di mahal yun. Of course, there are also limitations na because of high temperature processing, syempre mag-iiba din yung quality ng food, and you also have to consider the temperature at which you can process different types of food products. Like kung high sugar, syempre may chance na masunog yung produkto mo or what. In terms of number of applications, medyo limited ito, no, mostly for concentration of juices and ubiquitous tomato paste. Although, if you will crunch the numbers, obviously malaking part ito ng ating food industry or market. So whole companies make their income, millions of pesos or billions even, just by processing a few number of fruits.